Good morning and welcome to today's webinar. We are going to be talking about quantities and cost, specifically earthwork estimation and material takeoffs. For those of you here in the live version of the webinar, we want to keep this session very casual, so please ask us questions and engage with us through the Q&A section of the GoToWebinar panel. We will address all the questions at the end of the session. Here is our agenda for the day. Matt is going to start with a completed design. The alignments are already created, cross sections are set. From here, we will get subgrade volumes, aggregate volume, set up a custom attribute for costing, and then review our recommended material movement in the Opti-haul. I think this is the shorter introduction I ever had, so let's get in action. I'm going to pass it over to Matt Dickey, Softree Training Manager, and of course, Webinar Master. Welcome, Matt. Are you here?
I am. Thanks for the introduction, Katia.
Great. Let me just pass it over to you.
All right. So, thanks for the introduction. As Shadia mentioned, we're going to start with a largely completed design and pull out all the applicable MTO data that we might want to pull from it. If we're giving that to contractors, if we are the builder, it's useful for bidding and putting together your cost estimates, etc. So I guess we'll just start out by a brief rundown of material takeoff estimate itself. It's going to be a compilation of all the materials required to build our project. So we're going to look at how much dirt we're going to move around. We're also going to consider what kind of dirt we're moving around. So we've got ground types applied in there. So that's great for subgrade. Surfacing materials, it's largely the same. We're looking at volumes of aggregate for that. And then we have other things that we'd like to consider for that as well. So if we have culverts, those are useful to know for ordering for your project, having an idea of how much effort it's going to take to install them, etc. And so we'll look at culverts, diameter, length, whether we need couplers or not. And then we'll also assume that we want to revegetate the shoulders of our road. So we'll cover seating areas. So the volumes themselves, so the earthwork side of it, for the most part, aggregates are often really easy to account for. Just look at another window here. We've got just a cross section, and we've got our subgrade, which is quite variable, and then we've got our base course and surfacing layer on top of that. So we've got a fixed fill slope angle, fixed width for the most part. So really, for keeping track of it, it's not very hard. We can do it in the software, but it's just as you expect. The real benefit of using design software is the keeping track of things like your subgrade. So how much material you need to build that in your fill sections, how much material you need for fill, in your cut sections, how much material are you excavating. So that's kind of an overview of MTO. Before we get into the nitty-gritty of how to pull out that data, it's worthwhile to just talk about the design that I have here. So it's a relatively short design. I think we're right around the 2-kilometer mark. It's a fictional project that I've put together a while ago, but it could be anything. It could be a mine access road. It could be a forestry road, a resource road. It could also be a low-volume county road or municipal road. Got a design speed of 50 kilometers an hour. Some culverts in it. Yeah, trying to think, do I have anything else worth noting? Oh, of course, we've taken into account things like stripping. So we're going to assume that we've got an organic rich layer of soil that we want to get rid of before doing our excavation and earthworks to build that subgrade. So that's being accounted for. Just kind of outside of what I was going to cover, but it's applied in here. So in site prep, so we're removing a foot of soil, 0.3 of a meter. And what else do we have? We've got different materials. So we've several options assigned along the length of our road. I'm using hard pan, fractured rock, solid rock. These all have different geotechnical parameters associated with them, and different quality parameters as well. And we've also got some materials assigned to our surfacing layers. We'll talk about that a little bit in more detail when we get into the mass haul. All right, so I guess the most obvious topic to cover here first is let's just get our cut and fill volumes and look at it in a tabular form. So to do that, I'm going to open up a data table. Oh, of course it didn't show up where I was expecting it to. Let's see, view, new data table. And it's hidden off my screen. Let's see here. There. I'm running two monitors, so I just have to bring them over so everyone can see. And let's just bring up some other stuff there. All right, so we've got our data table. I've opened it. I've added it either over here or by clicking this button, or view, new window, and then we can switch windows back and forth over here. So my data table right now is showing me absolutely nothing. Let's configure this. So I'm just going to right click in my data window options, and then I've got this dialog box. So here, point types refers to the rows. So how often I see a summary of whatever I want to put in this. So I'm going to expand this. I've got profile points, plan points. All these are the different report points that are used to generate our volumes. They're also used to give us a rendering in 3D, calculate our cross sections, etc. So I don't necessarily want to see my volume summarized at all my profile points and plan points. I'm going to turn those off. What I want to see is just in a regular intervals. So I've got auto interval points 200 meters set up here. If I want to change this to an interval value, I can click properties, change the number here. I'm content with 200 meters for this, so let's leave it as is. Now, that's great. We've got our points, but we haven't defined the columns that are going to go into our table. So for this, we'll open this up. Of course, we want to know how frequent they're being populated, so we'll go to the different categories, and we want to go into our L line. So that's where our chainage is going to be. And let's look at the station. So hit OK, see what that looks like. All right, so we've got our stations in 200 meter intervals as expected. You don't have to go in and out each time. I'm just showing the process here. So we could also just add in all the columns that we're interested in. So if we're interested in our volumes, we can come to our volumes general, and we can look at our cut volume, fill volume. If we have bore and waste along the length of our road, we can show those as well. We do for this one. I should have introduced that with the design as well. I'll talk a bit more about that in a moment. And I also want to see so we mentioned the stripping volume. So we'll tabulate that. With the stripping volume, that's assumed to occur first thing. So if you have stripping applied to the length of your road, that stripped material gets removed first, and it's assumed to be disposed of. So that's not going to be included in my cut volume, fill volume, and it's not going to be included in my mass haul volume as well. And let's grab our surfacing layers. So surfacing layer 1 and 2. So we'll hit OK. And there we are. We've got a summary of things there. Now, let's go back in here. Page totals is going to give you the total for the extents in your data. Design totals is going to give you the cumulative volume. So just to show what I mean there, we can go in here and let's use 20 meter intervals instead of 200. And there, so we've got to how much 1,000 up. We go to the bottom, our cumulative values get higher. Excellent. So we've got that. There's a bunch of other options in here for what you can get from the data tables. So we've got different values here, and we'll touch on some of them. We won't touch on. Once we get the data table configured the way we'd like, of course, it's nice to be able to do something. I'm going to add that into our multiplot, so our design. Oh, we can come over here, multiplot, new subview, data window 1, and away we go. So that's nice if you want to include your material takeoff information in your design. If you're interested in sharing it with another software, so a lot of folks will want to take their tabular data and bring it over into Excel and to maybe summarize it in Excel, maybe do some kind of analysis with it, etc. So for that, the way I would go about that is right-click, copy data to clipboard. I guess we'll do it just for the heck of it. Over to Excel. Do a blank workbook, and just as simple as hitting save. Easy peasy. Probably going to get used less than just right-clicking. We can come in here and we can go to export data to ASCII. And we can, it's pretty simple, pretty straightforward. Just what we're talking about are volumes. Oops, I keep clicking the wrong button. I've just got my cut and fill volumes compiled as a whole. In our volumes general, we could also look at our different layers. So if we want to look at layer 1 cut volume, layer 2 cut volume, layer 3 cut volume, we could tabulate that as well. Oh, and I guess I already brought those over. I meant to look at my surfacing volumes before. So surfacing 1, surfacing layer 2. So there's our cuts by material type. So I've got layer 1, 2. I haven't added 3. It's easy to add 3. And I've got my surfacing volumes here. So the surfacing volumes, as expected, they're largely a constant where our stations are showing up in equal intervals and they are remaining constant. If I had a widening in my road, there'd be a little bump in the volumes. So let's just look at this a little bit more. If we are summarizing our surfacing layers, it's nice to be, or it's good to be careful to capture everything and make sure that you know what's being considered what. So here, I'm just going to right-click in the red hatch. I can see my hatch for subgrade, toggles that on and off. So that red, the lighter red is counting for my subgrade. If I go up here, hatch for subgrade, or for surfacing layer 1, toggle that on and off. Okay, so first layer above my subgrade is surfacing layer 1, and then I've got my surfacing layer 2 here. Now we can different surfacing layers to different items, different components. I have a spill apron applied over here. We can see what that is just by clicking on it and see what the options are. I've got a surfacing layer 10 in use too, so I should probably add layer 3 to account for my solid rock layer, and I'll add a surfacing layer 3. Let's go volumes. We can shift that up, so this is going to control where it appears in the list. And let's grab our surfacing layer 10. So there, that's configured. Now, we'll look at something a little different here. So we've got culverts included in our design. So let's do that in a separate data table. So my data table 1 still exists. I just minimized it. And we'll configure data table 2. So in here for point types, I don't care about those profile points or plan points. I want to have my summary based on culvert insertion points. For columns, I again want to see the station that they appear at, and then we'll go to the culvert section, and I want to see culvert diameter. And for an MTO, really only care about the diameter and the length. And we'll also care about couplers. But if we go through here, we'll notice that there isn't an option to include couplers. So we're going to write our own attribute for that. We've got that. There's our culverts. Now we'll assume that whether we require a coupler and the quantity is going to be defined by the length of our pipe. So in here, we're going to go to attributes, and we have an option to add something new. So let's call this coupler. Heading will be coupler, and description, number of couplers. For fields, I guess down here in the function, we can write our own formula to give us what we want. So if it was just something like variable x plus variable y, syntax for that would just be x plus y. For this, I want to round my culvert length up, divided by the length of a rolled pipe, and then get the number of culverts in there. So if you're not familiar with the way to write that, I'll just hit F1, and we can see that that brings us to the help, and we're provided with a few of the functions that we can write in the easier for us. So really easy. There's not a lot in there. You can do different computations with the options that are there. So let's add it. So I want to write ceiling. I'm going to pull from my field. So I want it to be a function of my culvert length. And divided by 10. So I'll assume I can get my culverts in 10-meter lengths. And let's hope that works. So that appears in my user defined, and then the variable is called coupler. And that's calculating away. And we can add it into our data table here. So columns and user defined coupler. And that's just calculating away. It'll just be a couple seconds, and we should get a breakdown of that. Here we go. So as expected, we have a 30 meter or 31 meter pipe. We'll need 3 couplers. So that's pretty slick. And again, just as we did with our volume table, copy data clipboard or put it into our multi-plot, etc. And away we go. One more thing, I'll just put it in with the data table that we already have on the go for the every equal interval. And there it is. And so seating area. So it's not going to be a volume. We can add that in by our data options columns, and then we get our planometric areas. So here, seating area, we get a description down here, slope area between road edge and slope stakes. That gives us the planometric area for it. We'll add that in. And away we go. So that's a nice tabular breakdown of our volumes, our culverts, do areas, etc. Now, that's great, and a lot of people will be happy just with that. It becomes, it leaves a lot to be desired if you are going to consider your material movement. So for most, or in a lot of cases, you may or may not care about your surfacing layers. So if you've got your aggregate for your surfacing layers is coming from a pit offsite, you're paying a flat rate for, you probably don't necessarily care to include that in your material movements. You just apply a per unit cost or per linear meter cost. If it's a project where we've got pits and we can manufacture that along the length of our road, so let's just see here what I have assigned, and I've got pits defined here, and I've got different materials in them. So I've got a well-graded material type there, and I've got my gravel there. So for movements, we can account for the surfacing material. It's up to you whether you include it. Now, I prefer to use a diagram as I'm designing, so I'm going to just add in a mass haul diagram to start. Mass haul. And this will take a moment to get. All right, there's our mass haul. Now, this showing my material surplus and deficits along the length of my road. So off the start, I've got a section with more fill than cut, so I'm generating a deficit. And then as we transition to cut, we're addressing that deficit. We zero out right around there, and then we create a surplus moving along. Now, this mass haul diagram, we can, by default, I'm using mass haul, and I don't have Opti-haul volume shown here. By default, it's just accounting for the movement of my subgrade. So we can add in our surfacing layers if we'd like. Surfacing layer 1, surfacing layer 2, and template layers, surfacing layer 1, surfacing layer 2. And there we go. So we're including that in our material movement in the mass haul diagram. Now this is perfect because we aren't using Opti-haul values. So the mass haul diagram itself, it's nice, it's a good approximation, it's been around for a long time. We can pull the data out of this and copy mass haul to clipboard, go back into Excel and paste that tabular data in here. And this is going to give us a breakdown of our material movements by category. So in here we've got it defined mass haul options that any movement under 100 meters is considered free haul. Any movement over 500, between 105 meters is overhaul, and beyond that will be our borrow, waste, or end haul. So yeah, we've got that. We've pasted for here. Here I've got my cut volume for each category. So at station 0 to 7.7, I'm generating a cut of 16 cubic meters. It's getting moved to a centroid at station 4.2. I guess that's basically nil. Let's look at something a little more interesting. So here we've got a cut centroid at 165 and it's being moved to station 25 and our volume is 500 cubic meters. It'll give us a direction as well, so push, pull, etc. This is pretty good, but it's imperfect because it's not accounting for our expansion compaction factors perfectly. So if I want to better account for that, I'm going to change my mass haul options. I'm going to use Opti-haul values. And since we use Opti-haul values, everything's going to be treated by the material type rather than the surfacing layers. So there, we'll add that in, and now everything's balancing perfectly. So with the Opti-haul calculation, it's actually taking into account which piece of individual material is being excavated, where it's being moved, how much it expands or compacts. So without Opti-haul, the cut factor is well defined, but the fill factor is ambiguous because it doesn't know the composition of how much fill from what is going into it. Opti-haul does. And we can see that's being balanced nicely there. Now, further to that, so this mass haul diagram is only showing me, it's kind of giving me a simplified view of how things are being moved. So I've got material going ahead. It's either basically going ahead or going back. In reality, my in situ material, and I've got my surfacing materials, and these are high quality material. So I can go in here, I can look to see that I've got my quality factor set as the best quality factor, and so it needs to be well base or better in order to use for my surfacing layer. So that adds a fair bit of complexity to the problem, and then if you want to take into that level of detail in your design, this is where I start to want to look at the Opti-haul diagram. So we'll look at that, and we can see in some places we get material moving in one direction and the other. If we hover over this, this gives us a breakdown of those. And if we copy this to our clipboard, so copy Opti-haul to clipboard, we'll just include everything. It gives us a much better breakdown of what's going on. So I'm going to skip over this preliminary stuff. We get a bunch of summaries, and then if we come down to the bottom, we get that mass haul table broken down by individual material type. So you know that I've got hard pan, I'm excavating it, it's going from station to station, distance of 8.5 meters, distance of 80 meters, etc., and we get the volume for that. So it's yeah, it gives you a really good breakdown of those. Well, great base, all coming from pit 4. So that is that. What else did I want to touch on? I think that's the majority of it. Of course, for the if we can see it in the plan, we can turn it on. Here. So we'll just choose whether we want our Opti-haul or mass haul or both. Just do everything, and there we go. Pretty slick. Yeah, I think we're ready for questions.
Thank you, Matt. I want to mention something. We have some comments in here. Some people are not able to listen the whole presentation. It seems like we are having audio issues. So I just want to mention that we are going to try to fix these errors in the video version that we post in our YouTube channel. For those who register to the session, you guys will get the video, the link to the video. So don't worry about it. Yes, we do have a couple of questions. The first one is, can I save my data table configuration for future use in other designs?
Good question. Absolutely. So if you've got well, for me, I've got a screen layout that I like to design with. So that screen layout includes the data tables that I'd like here. So let's just bring them up. So if we want those to be configured as I'd save my screen layout. So view, screen layout, save, and then if you save over normal, that's going to be what appears when you first start the software. If you want to toggle between different screen layouts, you can save it as a new name and then just access it in the dropdown. In the past, I've had one screen layout that I like to use for cost estimates and MTOs, and then I had another one that I'd like to design with. I just have the name differently here. Oh, and just close that. Next question. Open it up.
Yes, we have one more. Can I add an Excel table back into my project for the multiplot?
Yes, you can. Just a sec here. So it's going to open. So I've got my workbook here in Excel configured. Hit save as. Let's just save it in here and call it example. Now in my, that's calculating away. Actually, I think I can do this without letting that calculate. So in our multi-plot, if I want to add in it can be a document as well, but an Excel workbook, for example, we can go in here and insert OLE object, and that is going to be, it's going to take your whatever you reference and picture of it basically and refer to that here or wherever we place it. So we've got this, and let's browse. We'll select our example Excel file. We'll hit OK. And there that is. Now, if you want to play around with that a bit more, oops, if you want to change what's being visible, so if you don't want to show layer 1 or layer 2 for some reason, if we go to, I think it's page layout, print area, set print area, oh, and I was wrong. Do I have to save it? let's see here. And back in this, let's go wider with it. Print area, clear print area first, set print area. Yeah, it can be finicky to configure the OE object. I don't know why that's not doing what I wanted it to do. Oops. Oh, here, set this print area. Yeah, that updated. And then if we, yeah, so it's going to follow you to your worksheet. It can be kind of tedious to account for formatting just because we're working in two different programs and scaling is going to be funny and whatnot. But it can be done. So next question. That wasn't as smooth as I'd hoped it'd be, but
I think we don't have more questions, but if you guys feel that you need to send us another question, you can email us at support@softry.com. I want to thank you, Matt. It was a great presentation, and I want to thank everybody who is attending this webinar today. I hope
thanks everyone.
everybody has a wonderful day. Thank you and see you in the next webinar. Bye now. I hope
Thanks everyone.
everybody has a wonderful day. Thank you and see you in the next webinar. Bye now.
Thanks for watching another Softtree webinar. Please be sure to subscribe to our channel below or tell us that you liked the video. Thanks for watching.